Sometimes when you're given only a bit of information, it leaves the answer ambiguous, in which case you can end up with more than one answer. This is one of those cases. By drawing out the triangle that we're talking about, we should be able to narrow down what our options might be. So let's say we're told that we have sine of theta is equal to 7 over 12. Well, since it's positive, I know that I could likely be in the first quadrant here. This drawing is certainly not to scale, but again, I have that opposite, or y, over the hypotenuse ratio, and that is of course r. So we have this possible triangle here, but then I want to stop for a second because right here I'm saying that my y value is positive. Well, where else does that happen? Well, that happens anywhere in the first or second quadrant or above the x-axis. So I could also have a triangle right here. Again, not to scale, but the one thing that I'm missing here if I want to find all my trig values is I'm missing my x side or my adjacent side. So in other words, theta could be this angle or theta could be that angle there. Well, let's go ahead and find our missing value here. I'll go ahead and just call it A. So A is equal to the square root of 95, but if I put it over here in my secondary kind of position, or the second option that I have here, I'm going to have negative square root of 5 since the x values are negative over here. Well, as it turns out, I also need to distinguish between my two possible theta values or directional angles. And so I'm going to call one of them theta 1 and the other one theta 2, which means I'm going to have two different sets of trig functions. Before we move on, what I'm getting at here is sine of theta 1 or sine of theta 2 actually yield the same value. So let's go ahead and look at all the other trig functions. So I'm going to list those out. And from there, I'm just going to go ahead and use theta 1 first. I'll label all my sides. And then it's a simple matter of identifying the right sides and creating the correct ratios. So cosine is the adjacent side, square root of 95, over the hypotenuse 12. And tangent is just the opposite side, 7, over the adjacent side, the square root of 95. As it turns out, for cosine of theta 2 or tangent of theta 2, they're actually going to be the same. We're just going to have different signs. So I'm going to go ahead and just label those sides again real quick. And what we're going to see here is with cosine, I'm going to have the same lengths, but my adjacent side is going in the negative direction. So I'm going to get a negative square root of 95 here over the hypotenuse 12. And then for the tangent value, the opposite side is still 7, but again, my adjacent side became negative, so I'm going to get a negative value there. And of course, we do have our acronym as well, all students. So in this case, the only positive trig value is supposed to be sine. And that is how we can use information about one trig ratio to then figure out what the other trig ratios might be. In this case, because I only had that one piece of information, I could only narrow it down to two different possibilities. If I was given additional information, maybe told that tangent was positive or tangent was negative, I could have then figured out the exact quadrant and the exact triangle we were talking about.